Hello, grade 10s, and welcome to the magical, whimsical, wonderful world of the cast diagram. You were introduced to this cast diagram yesterday, and today we're going to dig deep into the different parts of the cast diagram. So sit tight. It is going to be a long video, but I've tried to make it as aesthetically pleasing as possible because I really enjoy this section, and I somehow missed what you're about to receive today. I definitely missed in high school, and I didn't understand what I was doing in trigonometry, so that's why I've decided that it's important to go through this cast diagram in detail because it will stand you in good stead for grade 11 and grade 12. So let's go for it, guys. Do you remember from yesterday we merely drew triangles in the 4 quadrants of the cast diagram? Okay, first things first, let's actually go over the fact that the cast diagram, you're going to see why it's called that now. The cast diagram has 4 quadrants. We're basically dealing with the Cartesian plane that has a y-axis and an x-axis, right? So that those axes divide this space into 4. Quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. Now, all 3 trig functions are positive in quadrant number 1 because of shade your rear, because x rays tan your exterior. All y's, x's, and r's are positive in quadrant 1, so that's why all 3 trig functions are positive there. Then only sine is positive in quadrant 2 because y, shade your rear, y is positive, a positive half of the y-axis in quadrant 2, but x is negative. So that's why tan and cos are negative in this quadrant. Then tangent is the only trig function that's positive in quadrant 3 because x is negative and y is negative, bottom half of the y-axis, left half of the x-axis. So y over x, which is tangent, will cancel out the negatives and tan will be positive in quadrant 3. Last but not least, only cosine is positive in quadrant 4 because we're dealing with the positive right-hand side of the x-axis, but the negative bottom half of the y-axis. So sine and tan, which have y's in their formulae, are negative in quadrant 4, but cos is positive. So if you remember these 4 letters in a row, C-A-S-T, it makes the word cast. Another way to remember it, and I actually like it like this because quadrant 1 starts with A, so we can say all. Quadrant 2 starts with S. All students take calculus. All right, or you can work out whichever way you'd like to remember this cast diagram. All good. Just remember quadrant 1 is always A. Right, so this cast diagram can be divided into 4 parts like we know already. Now, can you remember how many degrees are in a circle? Correct. You guessed it. It's 360 degrees. So let's think, if we divide the circle into 4 quarters, how many degrees would represent 1/4 of that circle? 90 degrees. So any angle that may be formed in quadrant 1, remember the triangles that we were sketching in the quadrants? Let's have a look at any angle, starting with that purple line, pinkish purple line. Any angle in quadrant 1 will lie between 0 and 90 degrees. I'm sure you would agree. Now, what I've jotted down in this pink rectangle is the 2 ways to represent 0 to 90 degrees. You can say theta is an element of this interval, 0 to 90, hence the word interval. This first option here is called interval notation. Or we can use our little inequality symbols, which we like to call crocodiles. You can say theta is greater than 0, greater than or equal to 0, but smaller than or equal to 90 degrees. And that option over there is called set builder notation. You don't need to know the names of the different notations, but you do need to know that these 2 things mean the exact same thing. They're just written differently. You'll never be asked about certain notations, but you will be given these notations, and you must know how to interpret them. Right, to re-emphasize what I said on the previous slide, sine theta is positive, cos theta is positive, and tan theta is positive in quadrant 1. See how this is the maths way of saying is positive. When you have greater than 0, it just means the sign of that trig ratio will be a plus. It will be positive. Now let's go on to quadrant 2. Any of these angles formed by this yellow ray will lie in quadrant 2, and I'm sure you'd agree that quadrant 2 starts at 90 degrees and rotates all the way through to 180 degrees. So quadrant 2 can be called the 90 to 180 degree quadrant. There's our one way of writing it. Theta is an E element of 90, semicolon to 180. Or the set builder notation, theta is sandwiched in between 90 degrees and 180 degrees. And because this is the S quadrant, you guessed it, the only trig ratio that's positive is sine in that quadrant. Okay, let's move on to quadrant 3. Look at how that purple ray rotates from 180 degrees all the way to 270 degrees. So theta is an element of 180 to 270 degrees, or you can say theta is sandwiched between 180 and 270 degrees, same thing. And quadrant 3 is known as whose quadrant? Who is the only positive trig ratio? Yes, T for tan theta. So over here, tan theta is the only positive trig ratio in this quadrant. Let's move on to quadrant 4. Look at how that blue ray of the angle rotates from 270 to what? One full revolution makes 360. So theta starts at 270 degrees and makes a full rotation all the way to 360 degrees. Sorry, not a full rotation, a quarter of a rotation. And such that cos is the only positive trig ratio in this quadrant. Now the next slide will just provide a summary of this one. So here's a summary of the cast diagram with all its relevant information. I suggest you take this down and refer to it always. Keep it nearby whenever you do trig in grade 10, 11, and 12. This is your Bible. Okay, have a look at the labels on each of the axes. I have said here 360 degrees is exactly the same as 0 degrees. Obviously, if you rotate through a full circle, you've gone through 360 degrees, but you've ended back up at 0. Okay, then that's where you've reached 90, there's 180, and there's 270. In each of these rectangles, I've underlined the trig function that is positive. So tan theta in quadrant 3 links up to the T for quadrant 3 over there. Okay, dokes, are you ready? Okay, so let's see if we can use our cast diagram to find the specific quadrants in which an angle lies. We don't know the size of this angle, but with this information given to us, we can determine if it's going to be in quadrant 1, 2, 3, or 4. All we need to do is whip out our little magnifying glass. Let's look at the piece of information number 1 that we've been given. You will always be given 2 pieces of information, and wherever those 2 pieces of information coincide, that is the quadrant in which theta will lie. I know that sounds strange, so just work with me for a second and you'll see what I mean in a moment. So if sine theta is greater than 0, it means that sine theta is positive. Let's underline that in a certain color and go and place a tick, a cross, a star, a heart, whatever symbol you like, in the quadrants where sine theta is positive. Now we know all 3 trig functions are positive in quadrant 1, so I've placed a pink heart in quadrant 1. Where else would sine theta be positive? In quadrant 2, of course, because of the big fat S that's right there. So we now know 2 quadrants in which sine theta is positive. Let's whip out our magnifying glass, be a detective, and think, where else can I get a clue? How is this information going to help me? Well, it says theta is bigger than 90 degrees, but smaller than 270 degrees. Let's imagine that we are an angle rotating through this Cartesian plane, rotating through 360 degrees. If you start at 0 and rotate through the first quadrant, you'll reach 90 degrees. Then you'll start rotating through the second quadrant, and voila, you are in a quadrant that is bigger than 90 degrees, as that notation requires us to have. So that orange heart needs to be in the quadrants that are bigger than 90 degrees but smaller than 270 degrees. So that's quadrant 2 and quadrant 3. Once you reach quadrant 4, you're already bigger than 270 degrees. So we don't place an orange heart there. Voila, voila, whip out your detective skills. Well done. There are two pieces of information coinciding in quadrant 2, and so the angle must lie in quadrant 2. It's as easy as that. Let's give another one a go. What if now tan theta is positive and theta is bigger than 90 but smaller than 360? Sketch the cast diagram to help you. Then let's look at piece of information number 1. Tan theta is greater than 0. So go and place a pink heart in every quadrant where tan is positive. Quadrant 1 and 3. Now let's look at our piece of information number 2. Let's go and place another color in the quadrant where theta is bigger than 90 but smaller than 360. So that's 3/4 of the rotation. Quadrant 2, quadrant 3, and quadrant 4. Theta would be bigger than 90 but smaller than 360. Voila, voila. Where do our two hearts coincide? In quadrant 3. Very good. Ready for the next one? Okay, grade 10s, I hope you're getting the hang of this. We're on to example number 3 now. If you're feeling unsure, maybe go back to the beginning of the video, or feel free to pause and contact me and have me re-explain something in a different way, perhaps. Anyway, let's give this a go. In which quadrant would theta lie if sine theta was negative? See how now I've changed it up a little bit. And theta is an element of 90 to 270. Let's have a look at our clue. First clue, sine theta is negative. So let's go make a symbol, any symbol of your choice, in the quadrants in which sine theta is negative. It's not A, because A is for all 3 trig functions are positive. S is where sine is positive, so it's got to be quadrant 3 and quadrant 4. The T and the C quadrants, that's where sine will be negative. Let's look at our next clue. Theta is an element of 90 to 270. So let's go and place a symbol in any quadrant that is bigger than 90 degrees but smaller than 270. I'm sure you'd agree that that is quadrant 2 and 3. Where do our two hearts cross paths? Where do they coincide? Quadrant 3, of course. Now we are told that cos theta is positive and theta is an element of 0 degrees to 270 degrees. Well, let's have a look using our cast diagram. Where would cos theta be positive? Quadrant 1 and the C quadrant, quadrant 4. Now let's look at our even interval and let's think, where would theta lie if it was bigger than 0 degrees but smaller than 270 degrees? Quadrant 1, quadrant 2, or quadrant 3, right? So you guessed it, the angle would lie where the two hearts coincide, which is quadrant 4. I mean 1, quadrant 1. Why did I say 4? Sorry. Well, we are on a roll. I know it's 14 minutes into this video, but hang tight. We're almost at the end, and I'm sure you are learning a lot. So stick with me for the rest now. We're at number 5. In which quadrant will theta lie if sine theta equals a half? Now, this is unusual. I mean, we've been working with sine theta is greater than 0 or sine theta is smaller than 0. So how are we going to interpret this? If sine theta is a half, which quadrant would it lie in? Well, let's think about the sign. It's invisible. It's a sneaky little guy. The sign in front of the number a half. A half is a positive number, right? So this is exactly the same as saying sine theta is greater than 0. They're just giving you a value here. And what you need to do is realize, oh, all I need to do is mark the sign of that value. So a half is a sneaky little positive. So sine theta is positive. Let's go mark the quadrants in which sine theta is positive, quadrant 1 and 2. Now let's look at the second piece of information, the interval. So theta is an element of 90 to 270. Hopefully by now you've got the hang of marking off your intervals. Bigger than 90 is but smaller than 270 is quadrant 2 and 3. And where do our two hearts line up together? The pink and the orange come together in quadrant 2. Now I would like you to just take note. I know the instruction of this example doesn't require you to make a sketch. All I asked of you was to tell me in which quadrant theta would lie. But what if I challenged you? What if I said, sketch a triangle in that quadrant that would represent theta? Remember yesterday we dealt with sketching triangles in specific quadrants. There in yesterday's lesson, you were given the coordinates so you knew exactly in which quadrant to sketch the triangle. Now that you've first discovered the quadrant for yourself by using your two pieces of information, pink and orange, you can go and sketch the triangle in quadrant 2. Remember that angles rotate in an anti-clockwise direction from the x-axis. So theta would rotate all the way from quadrant 1 into quadrant 2, and it would stop in quadrant 2. So that ray of that angle is going to become the hypotenuse of your triangle. Remember to always sketch your right angle against the x-axis. Don't go and connect that hypotenuse to the y-axis. And that's that. That's the sketch that you could use now to solve things a little further, but we'll deal with that in the next lesson. Let's try example number 6. If cos theta is negative 3 over 5, and theta is an element of 180 to 360 degrees, in which quadrant would theta lie? Well, let's look at our first piece of information. Cos theta is a negative number. Negatives are nice and obvious because the sign is right there. It's the positives that are quite sneaky. So I'm sure you can see negative 3 over 5 would mean that cos theta would lie in theta would lie in quadrant 2 or 3 because cos theta is negative in those quadrants. Let's look at our second piece of information. The theta is an element of 180 to 360 degrees. So let's go mark off those two quadrants. Bigger than 180 but smaller than 360 is quadrant 3 and 4. So it's plain to see that theta would lie in quadrant 3 where the pink and orange have come together. So now if you would like to challenge yourself, pause the video quick and on a rough piece of paper, just make a rough sketch of the triangle that you would sketch in quadrant 3. I hope it looks like this. X-axis and y-axis. The theta rotates in an anti-clockwise direction. I know it's so weird to see this theta on the outside of the triangle, but it is. It's an obtuse angle actually, but for ease of reference, we work with an acute angled triangle in quadrant 3. Note that the right angle is sitting against the x-axis. The hypotenuse of the triangle represents the ray of the angle through which the theta rotated. Remember, you get shade your rear because x-rays tan your exterior, x, y's, and r's. So your hypotenuse is an r, your x value would be your adjacent, and your y value would be your opposites. Okay, 2 more examples and then we're done. Let's use this cast diagram to find the specific quadrant in which theta would lie if tan theta was √3/3. Okie doke. So let's look at our first piece of information. Tan theta. What is the sign of that given number? √3/3. That is a positive. So let's go mark our positive quadrants for tan. Second bit of information, theta is bigger than 90 but smaller than 270. So let's go mark those two quadrants. From our little sketch on the left, we can see that theta would lie in quadrant 3 again, just like in example number 6. If we were to sketch that, we would repeat the same triangle that we drew in example number 6. Easy peasy. Last but not least, what if sine theta is a -3/5? Now, the negative is clear, so we know that we must go and make a mark in the negative sign quadrants, quadrant 3 and 4, of course. And this might be a little bit confusing to you because we haven't dealt with negative angles yet, but don't worry, we will deal with them soon. All you need to know for now is that if the rule says all angles are measured in an anti-clockwise direction starting on the x-axis, then a negative angle will oppose that. It will break the rule. A negative angle is merely an angle that also starts on the x-axis but is measured in a clockwise direction. So if you ever get a negative number that lies between 0 degrees and -90 degrees, it just means we are dealing with an angle that lies in the 4th quadrant. Okay, so this piece of information over here, -90 to +90, means that our angle will lie here from the bottom half of the y-axis, -90 degrees, and it will rotate through all the way to +90 degrees. So those two quadrants will be quadrant 4 and quadrant 1. There you can see that our two parts coincide in quadrant 4, and so if you were to sketch a triangle in that quadrant, note that the rotational path through which theta would rotate is really huge. It's starting from the x-axis, it's going in an anti-clockwise direction all the way round to quadrant 4, and bam, that ray of the angle will form the hypotenuse of the triangle that you need to sketch, and then we're going to connect that hypotenuse to the x-axis. Remember that your right angle must be on the x-axis. And that is that. Now the next slide represents your homework for the day. The next two slides actually. You have 3 homework questions. The first one involves finding the quadrant in which theta lies, and then question 2 and 3 are a little bit of a challenge, but you may check the memo if you're slightly confused, and the to-do list will also include the worksheet that you're about to see on the next slide. So thank you for sitting through this video. Well done. I'm very proud of you, and I can't wait to see how you progress throughout this section. Good luck and enjoy.